Here's an explanation for the answer to final exam question number 78 in Alternative Energy Demystified, 2nd edition. If you have the printed book, you'll find the question at the bottom of page 327 and the relevant figure, figure exam-7, at the top of page 328. And we're being asked, what is this a diagram of, a simplified functional diagram of? The answer is A. It is a binary cycle geothermal power plant. Well, let's look at the other choices. None of them really make any sense, and that's why you can eliminate it down to choice A if you have any familiarity with geothermal power plants. Magma-driven. Well, no, the magma would come right up out of the ground and drive it directly, and I don't think I've ever heard of something like that. I mean, you put it right on top of a volcano and use the actual magma from the volcano. I think that'd be a little bit of a dangerous proposition. I'm not sure how long the plant itself would last if the volcano decided to get out of hand, so choice B is rather silly. Choice C, liquid water-driven geothermal power plant. Well, there might be some plausibility to that. We'll look at the diagram of that in a minute, but that's not what it's called. Technically, it's called a binary cycle. Triple cycle, I don't believe I've ever heard of that. Fuel cell geothermal power plant, I don't think I've ever heard of that either. So let's actually just take a look at figure exam-7, which I have rearranged the geometry of somewhat so that it'll fit a little better on the screen, but it's the exact same interconnection amongst the components. There's a groundwater pump, pumps water down into the ground, and then the production well comes up and produces energy for the heat exchanger, and guess what comes out of that heat exchanger? Steam. Drives a steam turbine, an electric generator, goes to the power lines. This is a familiar refrain in power plants. These components right here, the steam turbine, the electric generator, and the transformer, which steps the voltage up to whatever voltage is necessary to be transmitted over the high-tension utility lines. The steam then is condensed, goes back into a feed pump, so we have a cycle here which produces steam, condenses it back into water, boils it in the heat exchanger, makes steam again. So that's one cycle. The other cycle is this one right here. That's why it's called a binary cycle, because there are two cycles in operation here. So this is what we're getting for our money here. This is where the energy is coming from, up out of the ground. We pump water down into the ground, and that gets heated up, comes back up out, flows through a bunch of cracks in the earth and everything. There is some controversy about pumping stuff down into the ground. This is just plain water, but nevertheless, once you start fooling around with the underground rocks and formations and things like that, fracking is one good example of something similar to this, which has been implicated in a lot of unsavory results, as well as producing plenty of energy. So there's a plus side and a downside to all of this. One of the neat things about this is that if you want, you can actually boil this water that comes up out of the ground and get fresh water, even if you put salt water down into the ground. That's a desalination or desalination of seawater. Can be carried out in conjunction with this process of obtaining geothermal electricity, or electricity from geothermal sources. But once again, this is called a binary cycle geothermal power plant, and once again, that is choice A.